All right, this is the copy of the notes. There's a basketball hoop on top. You see this picture. Look for this picture on these notes, and that's how you'll know you got the right ones. It says Geometry Notes 11.4 and 11.5. Now, remember, this does not match up with your book. This is something I had from a previous school, and I liked it because it kind of gave you some examples to look at so you could get the idea. I know you can't hardly read what's on here, but just make sure you're just looking. You can read along. If you have a hard time, you can read along on your copy of your notes because this is blurry. I'm just trying to show you where to put the words on the notes. All right, the first thing, an inscribed angle is what you want to put in this first blank. So it's INSCRIBED, and I'm just going to put an angle symbol here, and you can abbreviate that way if you want to. An inscribed angle is an angle whose vertex is on a circle. Okay, so let's look down at example 1. Here, angle R, MRP or PRS, either one of those would be inscribed angles because its vertex, where the two rays meet and make that point, that's on the circle. And whose sides contains chords of the circle. Okay, so whose sides contain chords of the circle. If you look at, for instance, angle MRP, the vertex is at R. That line right there is a chord of the circle, and that line right there is a chord of the circle. That's what they're talking about. I'm going to clear that writing off now, though. But anyway, I think it helps to look at that example down there. An intercepted arc, okay, so in this next blank, an intercepted arc, and you spell arc A-R-C. An arc is a piece of the circumference of a circle. Okay, an intercepted arc consists of endpoints that lie on the sides of an inscribed angle and all the points of the circle between them. Okay, so what does that mean? If you look down here at the example in the box, DF is an intercepted arc. Let me choose another color here. There's an angle here, angle E, and its sides are here. The sides, that would be an inscribed angle because its vertex is on the circle and its sides are chords of the circle. But the arc, the piece of the circle, the piece of the circumference of the circle that is intercepted, DF, that is called an intercepted arc because an arc is just a curved portion of a circle. Okay. When we have an arc that's less than half the circle, we call that a minor arc. So for instance here, DF would be a minor arc. And if I look at the rest, let me get another color. If I look at the rest of this circle here that wasn't contained by that blue arc, DF, that larger part of a circle, do you see how it's bigger than half the circle? Since it's bigger than half the circle, we have to name it with 3 letters just so you know how to trace that arc off, because then you might think, oh, I'm supposed to do that shorter little arc there. But that green arc is called a major arc because it's more than half of the circle. Half of a circle would be the semicircle, right? Okay, so if we got less than half circle, minor arc, more than half the circle, major arc. Okay, moving on to the measure of the inscribed angle is always half the measure of the intercepted arc. So, for instance, if we're looking at our example here, I'm just going to write over something here. If I want to know what is arc, what's the measure? Remember, M means measure. That's how much it is. The measure of arc DF is equal to, you could write it this way. The arc is equal to twice of angle E, or 2 times the measure of angle E. You could write it either one of those ways as saying the same thing in case you ever see it on a paper. Or I could say the measure of angle E, that inscribed angle, is half, goodness, I can't get it to write today, it's half of the arc, the measure of arc DF. And again, you might see that written angle E equal 1/2 arc DF. Okay, we can measure arcs in degrees Or we can measure it with like meters or inches or centimeters, like with a ruler. Usually we want to talk about the length of it like a ruler, but we can refer to it in terms of degrees also. So that confuses a lot of students, but there are two ways to talk about it, and you always need to be clear about what you're being asked for in a problem. Okay, let me see if I can't get rid of some of that. Okay, so now we're looking at problems 1 and 2 on the first page. They want us to know what is the measure of angle. You got to pay attention to what it's asking you. Angle, PRU. So let's trace the angle. Oops. The angle, I'm going to trace it. I'll trace it in red. PRU. I'm kind of off there. The stylus sometimes takes where I don't want it to. That's that angle. Okay, now if you notice that if you remember the rule we just talked about, that angle there, since it's an inscribed angle, it's going to be half of whatever the arc here is. Well, they've labeled the arc 118, so we're going to say half of 118. See, half of 100 is 50, half of 18 is 9, so that would be 59 degrees. Here we're going to talk about it in degrees, even though on other lessons we've talked about arc measure, another way. Okay, so the measure of angle, PRU, is 59 degrees. Now, on your paper, something is missing. Some printers will not print, and mine won't, this arc symbol. It's not like it's part of its package or something. So if you see something like measure SP, it can't be an angle because there's not 3 letters. So where is SP? SP is here. I'm going to mark it in green. Now, you have angle R. They tell you angle R is 27 degrees. Well, the angle is always half of the arc that it cuts off on that circle. If you want to look at it that way, it's the intercepted arc is where that arc is cut off, the piece of the circle that's cut off by that angle. So it's going to be double whatever the angle is one way to look at it. So the arc would be 27 times 2, which is what, 54? So the arc here is 54 degrees. Notice I can't really talk about this in terms of a length, this arc, because they didn't tell me what the radius was. So that's one clue that you're not going to put down a number and use that other formula for an arc. Okay, so looking at number 2 now, it says, what is the measure of ADC? ADC cannot be an angle because remember the middle letter, when we name an angle, the middle letter has to be the vertex. And if you look over here at D, which is the middle letter, there's not an angle there. It's an arc. So what should be here? You need to put an arc on your paper. They want to know what is the measure of, well, I'm going to trace it now. I'm going to go from A. It's kind of like connect the dots. A to D to C. Woo, that's a big old arc there, isn't it? That's a major arc, for example. That's what we would call ADC. So that arc, what we're looking for is what is cutting it off. What cuts that arc off? If you look, and I'll use a different color here so you can kind of tell where I'm talking about, there is an angle right here. It goes from there, and it goes to C. Hard to see on this copy. Look at your paper. And they tell us this angle right here is 135 degrees on your paper. Well, if you remember, the angle is always half of the arc. So if the angle is half of the arc, I would double the angle to get the arc. That's kind of hard sometimes to keep straight, I know. 2 times 135 degrees would be, what, 270 degrees would be that arc measure. Make sure you put the degree unit on it. A lot of teachers that I know, math teachers, would count it wrong if you don't put the degree on it. And so just be real careful to put your units here. Now, what about the measure of angle DAE? Okay, so DAE, I'll use a different color so we can see it. It's this angle right here. And if you notice, this angle cuts off the arc measure that they give us is 76 degrees. So how do I find the angle? Well, the angle is half of the arc. So I would say, well, what's half of 76 degrees? And remember, you could just divide by 2. Isn't that what half is? So half of 76 degrees, let's see, half of 70 would be 35, and half of 6 would be 3, so that would be 38 degrees. All right, our corollary for this bottom example on the bottom says if inscribed angles of a circle intercept the same arc, then the angles are congruent, okay? So if you look here, we have the arc AB. We have the arc AB, sorry, I'm having issues, right here. Now there's two angles that intercept it, at least two. Let's see, more than that maybe. That one intercepts it. BCA intercepts it, or ACB is what they call it here. So I'll circle each one as we outline it. Then ADB right here also intercepts it, sorry, I'm saying the wrong word. And then if you look, there's even another one, and it is AEB. So we go from A to E to B. They all intercept that blue arc. So what I know is those angles are all equal. Angle ACB is congruent to angle ADB, is congruent to angle AEB. So here's the deal. You can I've got really complicated problems over this stuff. And what you have to learn to do, I still cannot get AEB, so you want to write it big. That's what should be in the last blank, AEB. It's these three angles that I circled down here. So what you do in problems is try to figure out what can I see that might intercept the same arc. Maybe I could find out some measures of some angles just because maybe there's more than one that intercept an arc or something like that. So this sort of thing, you can get really complicated. So it helps to kind of do what I do here and use some different colors sometimes so you can keep track of what you have.